Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to share with you some concepts with data frame cache while working with Spark. Okay, and around this many interview questions can be formed. So this is a very vital or important topic I can say, because personally while giving interviews across various product based companies, I faced questions around this particular concept what I am going to cover. So try to understand this topic, and if you have any doubt at any point of time, feel free to ask in the comment section. I'll try to reply back as soon as possible. So already you might be having some basic intuition about data frame cache. That is basically we save data frame state in the memory if the data frame is used across various transformation. So that way we no need to recompute the same thing again and again, right? And we will get the outcome faster. That is the major reason why we use data frame cache in Spark, or in general why we use cache or cache. So just let's have a quick recall. So as a first step, what I will do, I will import everything from the functions from pyspark.sql.functions import star. And then here I am going to read one S3 location which is mounted using this particular code in Databricks DBFS file system. Okay, so here you can see test cache is the mount location name. Here whatever we have given this mount path, and this mount location is pointing to this Delta Spark testing bucket. So here if you see, we are having Delta Spark testing bucket. Within that ID's data is the folder. So based on that, here I have given the complete path. I am reading the CSV files available in this S3 path, and here we are having various classes for ID's data set data, which is having by default ID, sepal length, petal width, and class name as schema. So after reading this data as CSV file format, I am applying group by on input file name. That is basically from each file how many rows are coming, that if we want to detect, then we can utilize this kind of code, that is group by input file name. And then on top of that, we are applying count operation, as simple as that. So I will run this code. So here this particular information is little important because it will help us in understanding one concept later. As you can see, versicolor and virginica is having 51 and 50 count respectively, and Setosa and another category, these two files are having 27 count, right? This is pretty much simple. Now what we'll do, here I think already I have imported this, so I no need to execute this cell. I'll delete this one. And now I am applying this specific operation. That is, I am applying group by on class name column. So if you check the data frame data, df.show 5, maybe if we do, here this is our default schema of iris dataset. On top of class name, I am applying an aggregation, and I am taking sum of sepal lengths. Okay, and then I am applying order by based on the sum of sepal length, and that data frame data we are returning. Very simple transformation we have applied. So here we are getting the result or outcome, right, where ID's virginica is having highest sum of sepal length. So now let's open this Spark jobs tab and let's see what is going on in the backend. We'll try to have some sort of intuition. Okay, so here I will expand this in a new tab, and here you will see an option of associated SQL query. So these tab often useful to understand intuitively what is going on in the backend of Spark. So you can click on this, and then here if you completely scroll below, here as a first step it is scanning the CSV file from the external stage, whatever we have mounted in Databricks DBFS file system, and from that it is reading 155 rows, right? So 155 rows are coming basically from all these four files together. 51 plus 50 plus 27 plus 27 is equal to 155. Okay, so that 155 rows it is reading from the mount path, and after that it is applying this computation, right? There is no cache is getting applied because from the job tab itself, here we can see that it is going to scan the CSV file from S3 stage. Okay, and one more location I would like to highlight. Here you will be getting a storage tab. So try to understand intuitively. When you apply cache or cache, that time in local system, Spark stored the data frame in memory storage, right? So in the storage block, we should be able to see. But if you see here in the storage section, here no data frame is stored, right? So it is just reading the data from external file system, but it has not stored any data frame or RDD in memory because till now we have not applied any cache, right? Now here what we'll do, we'll apply df.cache. Okay, so that way in memory, this specific data frame, whatever we are reading from this external stage or mounted path, that whole data will be cached. Ideally this should happen. So now let's see the storage tab after execution of this cache command, right? So here I will refresh the storage tab, and here still you will see that no data frame or RDD is available within our storage of this cluster. So this thing we can conclude from this UI part. Perfectly fine. Let's go to the next query and let's try to understand what is happening. I will execute the same transformation. First group by on class name, then on top of sepal length we will be doing a sum operation, then we will order by based on sum of sepal length for various classes. As simple as that. And I will run this command. So here this command is executed successfully, and here this time you can see there are 3 Spark jobs. So let's open the job, and I will open in a new tab. So I'll maybe take this to the last tab to avoid confusion, and then again we'll go to associated SQL query. So here if we go to associated SQL query, and if we scroll below that from where it is reading the data, you will see it is still scanning our CSV data available in external storage, right? And 155 rows it is returning. So now you might get little confused that although we have applied on the previous cell df.cache, that means ideally while executing this transformation, it should read the data from in memory. Why it is going again to external storage location to read the complete CSV data? That is a vital question, right? So the answer is cache is a transformation. It is not an action. So it follows lazy evaluation pattern. So because this is a transformation, so it will be only getting executed whenever an action will be called. And here if you see in this code, we are applying .show. That means we are calling an action. When this action we are calling, then it is executing this df.cache as well. And to execute this df.cache, it should get the df. So to get the df, it is basically executing this specific cell, right? Spark.read format CSV from external stage. And that's why in this specific tab, you are seeing scan CSV. So in the backend, what is happening? Again, I am repeating that if you go to this command, this one, so due to .show, the cache transformation is getting triggered, and cache required this df data frame, and this data frame is getting generated by scanning the CSV files from external storage. That's why when this group by operation we are executing in this SQL data frame tab, we are able to see this scan CSV. So this scan CSV is happening majorly due to caching the data frame data. That's all. I hope you are getting the sense. So job tab we have inspected that there is not much difference in this case. We have observed same like earlier group by also, it is currently also scanning the complete external storage location. Just the reason is different. Earlier it was scanning due to this group by operation itself. This time it is scanning due to the cache operation. But now this time if you go to the storage location, you should see that the data frame is cached. So this is our earlier storage picture. Now if we refresh this, here you will see that RDD is available, and it is also showing that how much data it has cached. It has cached 100%, and all 4 partitions it has cached. If you want to double confirm, here you can apply that also. df.rtd.get num partitions. If we execute, sorry, this should not be within parentheses. So here you can see 4. So maybe 4 partitions are getting generated because there are 4 files available, right? So overall the point what I'm trying to say is that in this particular process, the complete data frame is cached, right? So that you can observe from here. There is cached partition is 4. That means complete data is cached now, right? So till now, whatever we have covered, as a conclusion, we can say that if we simply apply df.cache and if we expect that the next transformation will be running faster, that is not true. And the reason is cache will only happen whenever some action you are calling. So as a result, in industry standards, what we do, that let me show you. So before showing that, I will unpersist this data frame. So I'll execute this unpersist and it is done. Now if we go to storage, this RDD should be deleted because we have unpersisted the data frame. and you can see it is gone. Perfect. Now in industry level code, whenever we want to take help of the cache functionality, we apply by default a simple transformation which will make sure that all the partitions it is reading and caching in our memory. So cache.count. So when I'm applying .count, that means Spark actually need to read all the partitions. It is not like it will read the partial data frame or partial partitions, right? And that is the reason we use count operation, so that all the partitions will be cached. So if we run this one, here you will see that it is giving 155, although that is not actual reason to get the count. Actual reason was to cache the data frame. And here you can see our data frame is cached, and here you can also see that fraction cached 100%, cached partitions, that is all 4 partitions are cached for this data frame, right? And this data frame has 4 partitions we have already seen using getNum partition. Perfect. Now what I will do, I'll now execute this group by command. Okay. So this group by command is a special command, because till now whatever group by command earlier we have executed, for none of them the data frame was cached. But this time when this group by command will be executing, before that the data frame is already cached, right? So now we'll inspect what is happening in job tab in SQL query section. So I will run this cell, and here it is done. I'll go to jobs tab and I'll click on view. I'll maybe open in a new tab, and I will take it to the complete rewrite section, and I will go to associated SQL query. And if I scroll below, earlier we have seen that whenever scanning from CSV was happening, here 155 or 154 it was showing. That means it was actually going back to the external storage location and reading the file. Like here, I think that cell is open. Yeah. So here this is our previous group by. You can see it is scanning 155 rows from the external storage location. Then the first group by, if you see, same goes here 155. But after caching, when we are seeing, it is 0. That means it is no longer need to read the data from external storage location, because in memory, due to cache operation, the data is stored. So if you see here, there is a step called in-memory table scan. Previous to that, whatever data it is shifting, all are 0, 0, 0, right? From in-memory table scan, it is reading whole 155 rows, and on top of that, it is applying aggregation operations, whatever we tried to do using this group by command. And that is pretty much intuitive. I hope you are getting this, that's what the ultimate goal of using cache. That already we have read the data from external storage, that is from S3 location, which is mounted in Databricks local file system. And now that data we have saved in our compute platform in the storage, right? So that's why it is doing in-memory table scan. It no need to fetch the data from CSV. That's what I tried to show you, right? And now what I will do, I will again unpersist the data to show you another important thing. Data is unpersisted. Now if we go back to the storage section and refresh the screen, here you will see that saved RDD is gone, right? Perfect. Now I will again cache the data, but this time instead of caching the data using .count, I will use .take10. Okay. Basically in this demo, I want to show you what is the importance of immediate next action, what we are calling after .cache. So here I am applying df.cache take10. df.cache is to cache the data frame, and .take we are applying because this is an action. So that way actually data frame data will be cached, right? So here I will run this one, and here it is basically due to .take, it is returning the row objects. Now let's see how the storage section will look like. So here if I refresh now the storage section, here observe a very vital point. Earlier when we were applying .cache using .count, that time it was showing fraction cached 100%. But this time when I have applied .take as immediate next action, then here it is showing only 25% of data is cached. And here you can see cached partitions are 1. Okay. And why this is happening so? Let me tell you. So in Spark, it cached only that much amount of data or that much amount of partitions, how much is required to perform immediate next action. Okay, try to understand. So df.cache, this transformation will only cache those many partitions, how many partitions are required to perform immediate next action. So if you see the immediate next action, earlier we were applying .count. and count need all the partitions to read, right? Then only it will give you the absolute count for our data frame. So because count operation require all the partitions, that's why cache was happening for all the partitions, right? But this time when I'm applying .take, it is reading only one partition, and that partition is ID's particular file. Whatever partition got generated due to reading of this particular file, that partition alone itself is sufficient to perform this .take action. Because how generally take works is, it first try to read one partition. Suppose in that partition there are 20 records and you are applying .take of 10. That means 10 records you will get from the first partition itself, because within that partition itself we are having 20 records, right? So it will not read another partition. But suppose in a partition you are having 20 records and you are applying .take 30, that time first 20 record it will take from one partition, and for next 10 records to fetch it, it will go to another partition scan, right? But in our case, we have already seen that we are having total 4 partitions, each from one file. And in each file, we are having more than 10 records. So that means .take operation can be fulfilled by reading only one single partition. And that's why the cache of data frame is happening only for one partition out of 4. That's why 25% data is only cached, not the complete data. Very vital concept. So always remember that in Spark, it will cache only that many partitions, whatever number of partition is required to perform immediate next action. So I hope it made some sense. It will be more clear when I will execute this cell now. So now I will apply group by and will inspect how it is working. Because this time it is a mixed case. Some data is available in our memory, here 25%, and rest data is available actually in external storage. It is not available in memory. So we'll observe what is happening. So I'll simply run this tab. That is done. I'll go to Spark Jobs, click on View, and I'll open in a new tab, and I'll go to Associated SQL Query. And if I scroll below, here this time you will see that scan CSV is returning some rows. When I have applied df.cache.count and complete data frame was persisted in memory, that time scan CSV was not even required. It was returning 0 from this step, right? If you check the earlier data, scan CSV was returning 0. But this time it is returning 104. How this 104 value is coming? Try to understand. So overall, when we have not applied any caching functionality, that is the first stage, when we have applied group by for the first time, it was going to the external stage and reading complete data from there. And that time it was extracting 155 rows, that is all rows from external storage location, right? And after applying cache in this layer, here it was returning 0 rows from external storage. But this is a mixed case now. Some data is stored in cache and rest are not available in memory, so it needs to go back to the external storage location. So if you scroll up here, in memory table scan also it is doing. So in memory table scan, in this memory, how much data is stored, try to understand. So here if you see, it has basically cached ID's versicolor data. And ID's versicolor class, if you see, ID's versicolor, it is having 51 rows. So basically 51 records are coming from cache data. And totally in our data frame, when we have applied df.count somewhere, we are having 155 rows. Out of this total 155 rows, here if you see 51 rows, that is basically ID's versicolor one. This 51 rows is already available in memory. So 155 minus 51 is how much? 104, right? So that 104 rows, it is reading from external storage. So in case of mixed scenario, when partial cache happened, Spark intelligently read only those partitions, whatever is not available in memory or whatever is not cached, for them alone it will go to external storage and read the data. But whatever partition is already cached, it will read from in memory. So in this case, one partition from in memory, rest 3 partitions from external storage, hold together 155 rows only. It accumulated in this step, and then after that it has applied its normal group by and transformation, right? So I hope you got this very vital concept that in case of partial cache data frame, it will read those partitions whatever is cached from memory, and for rest partition it will compute the complete DAG or all the previous transformations whatever is required. This is one of the very important conclusion. Second very important conclusion is cache is a transformation. It is not an action. So never expect that if you apply simple df.cache and the next transformation will be faster if you are working on the same data frame, because cache get triggered only when you apply some action, and you should opt for that kind of action which require all the partitions from our data frame, so that it will have 100% data cached instead of fractional data cache. So most of the time in industry we apply cache.count, so that way all the partitions will be required to apply the immediate next action after cache. As a result, all the partitions of our data frame will be cached in memory. Correct? So this is all for this video. I wanted to cover this concept and I went very slow because this is a very vital and important concept, little bit complex too. But this kind of Spark UI from Databricks notebook really make it intuitive to understand. So try to play with this particular code base which I'll be providing in the description box, so that you will understand more out of it. And this is a very vital topic for interview. In many product-based companies, in my past experience, I encountered questions around this. So I hope you will find this video helpful. Please like, share and comment if you got some insightful concepts from the video. And subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.